If you clicked in, you probably want to learn destruction effects in Houdini. Am I right? Well, this video is going to be the perfect way to do that. If you're new here, my name is Matt Sola, and on this channel, I learn and I teach destruction effects in Houdini. And today, we will try to recreate this effect you see on the screen. A pile of wooden boxes or pallets collapsing on each other and making this colossal mess and chaos. It's going to be a lot of fun, and we're going to pick up a bunch of new things and tricks and techniques along the way. You are welcome to follow along by firing up Houdini. Also, you're free to binge watch this, whatever suits you. And before we begin, a little housekeeping. I'm going to pause the simulation. A little housekeeping is I'm going to be including a HIP file below this video. If you want to follow along, all you have to do is download this HIP file from the comments section of this YouTube video, get it on your desktop or whatever folder you're working with, and open it up in your Houdini by going File, Open, and open this file, and you're going to be able to start from the point I'm going to start. All right. Next thing I want to say is a huge thank you to the followers and subscribers of this channel and people who comment and ask questions and kind of make this a cool community of people who want to learn destruction effects. So I really appreciate each and every one of you. And you're also welcome to ask questions, fire away any concerns in the comment section. You can use it basically for anything that you like. And I'm going to answer to you, and I'm going to try to troubleshoot any problems and things like that. All right, with that out of the way, the first thing we need to do is go to File, Open up the file that I just showed you, and we're going to start, okay? And the first thing that I'm going to do is I'm going to start from the point that you are going to start from. And that is going to be, so I'm trying to explain what I'm going to do in just a second. So let's see. So what I'm doing is I'm copying what is in your HIP file at the moment without destroying the work I did. So if everything is okay, you should be starting from this point, okay? Putting a display flag to the color node, and when you do that, you're gonna see this palette, okay? So this is the wooden palette we're working with, and the way I created it is very simple. I was basically creating a bunch of simple planks and shapes and merging them together and kind of creating this structure that kind of follows how a typical wooden palette would be. Adding different match size nodes and a little trickery in between, and the final result is this. And if you want to reconstruct it and dissect and learn how it was done, probably the best way for you is to try to read this network best of your ability. All right, that out of the way, what is the next thing we need to do? Well, how about we try to fracture this palette? Give it a little bit of, because at the moment, if I put wires on it, you can see that it's a solid mesh. Obviously, there's no intersection or anything, so it's simulation ready, basically. But I want to start fracturing it. The way we can do that is take our mouse over this color node, press tab on our keyboard, and bring out a node called RBD Material Fracture. And then when I do that, you're going to see there's a node called RBD Material Fracture in the menu available. So I'm going to click there. And then when I do that, Houdini is going to think for a second and is going to, when I press down R and display the node, is going to start to think about how can it shatter the geometry, or should I say fracture it in various pieces along the whole geometry. But at the moment, the result is not what we are looking for. We want this to have a wooden grain, how a wood would typically basically fracture, right? So I'm gonna, with this node selected, press P on my keyboard, and what's gonna happen is a settings for this node is going to pull up. And this is where we can specify how we want to fracture this geometry. And there's a handy dandy material type dropdown available. At the moment, it's set to concrete, but it is not what we want. We know that we are working with wood. So how about we change from concrete to wood? And when I do that, Houdini is going to try to fracture it and give us some kind of result, something like this. And you can dabble around with the settings further. You can basically take this fracture by piece, and it may or may not give you the results you're looking for. And you can see it kind of gives each plank up maybe a little bit better look. So let's see. I'm gonna pull it off. And when I turn it off, I actually like how it kind of fractures the geometry along these planks going horizontally. So I'm gonna stick with this option right here. Next, what we want to do is we want to go to the constraint tab here. Now let me actually pull this up. So there's a constraint tab here, and constraints, as I have in previous videos mentioned, you can think of constraints. Actually, I'm gonna visualize this so you can learn as we go. Oops, not this one. We want to pull out a node called null, and null node helps us in different kind of scenarios, and this is one of those where we want to take the middle pin out of the RBD material node, which is gonna set constraint geometry. I'm gonna plug that into the null, and I'm going to set my display flag to it, and there you see, this is what constraint geometry is. And if I mouse over to the display point numbers, and actually points here, I can see that all that constraints are just primitives with a point on each end. And that is what basically governs the relationship that's going to be established between each of these pieces, okay? And if I pull down another node called RBD, RBD explode, okay, and take the first pin and connect to the first pin of the RBD exploded view, put my display flag to it, we can see that indeed we have multiple fractures happening in our wooden pallet. Exactly what we want. Now, and when we look at the constraints here, actually I can maybe put here like this. These lines going in all those directions are what establishes this connection and basically governs how these pieces are going to react to one another when they're simmed. So I hope that clears that up, what constraints are. But I'm gonna get rid of these two nodes, so I'm gonna select them, press Alt-X on my keyboard, and that's going to get rid of those. It was just for the visualization and explanation of what constraints are as we go along here. Very important, actually. Select the RBD material fracture node, press P on my keyboard so I can see the settings once again. With the constraint tab clicked or selected, I want to say disable constraints because I want to create my own custom network of constraints. So I have a greater control of how they're built. And in my opinion, that's gonna give us a much better result. Okay, for that, that's that. Enable clusters can be the same details. All right, what else can we do? Well, I think for the most part, we're good in this department. Well, how about we take this pin and start creating our custom constraint network. And to do that, I'm going to type in RBD constraints from rules. And you don't have to type the whole name of the node exactly as it is. You can say rcon. And from the list, you're going to see that indeed you can find it here. If I can see constraints. So let's see. Oops, not this one. RBD Constraints from Rules. And there we go. I'm going to drop that down in my graph here. And I'm going to work with the first pin that comes out of the RBD material fracture. I'm going to plug it in to the first input of RBD Constraints from Rules. And I also theoretically could take over the constraint geometry, but we no longer have it on our RBD material fracture node. See, if I put my display flag to null and try to kind of visualize that, they're no longer there. Why? Well, because we took the constraints and said, please disable them for us. Okay, well, what we can do here is we can pull up these settings for this node. And in the connection type, we can choose from different basically settings. We can do surface points, and that is going to give us a surface points, which is probably a little heavier on our system, but we can maybe use hinges, and that could perhaps do that for us. But in this specific wooden pallet scenario, I want to create a center of mass. And when I do that, you can see a bunch of connections now appear on my geometry, which is great, exactly what we want. And what I want to do now is with those two set, well, let's review a little bit. Well, we have created basically the fracture on our geometry, which is exactly what we want. We have created the constraints, which is exactly what we want for our sim. Well, how about we start clustering some of these elements together? Because right now, if I pull down another node, which is exploded view, previously we looked at RBD exploded view, but this is a little bit simplified node and doesn't really have that much control, but for what we want to visualize now, it's going to be exactly what I want. So you see, if I pull this uniform scale slider from the right to the left, you can see that all of these planks are basically the same. They're not grouped in any chunks or any groups or anything like that. But if I could do that, that would be ideal, right? Well, we could do that. And the way we can do that is we can take the first pin coming out of the RBD constraint from rules node, take it out, press tab on our keyboard, and type in RBD cluster. And when I do that, there's a node popping up called RBD cluster. Well, let's click on that. And automatically, it created this connection for us. And if it didn't for you, it's not to worry about. We can hold down, oops. Hang on, what happened? I'm trying to revert back to the results. Actually, I'm gonna start all over again. So I'm gonna pull down RBD cluster, and it should automatically create this connection for you. But if it didn't, you can press down Y on your keyboard, and you're gonna see there's a scissors icon that pulls up on your mouse cursor. You can press left mouse by holding down Y on your keyboard and zig through these wires. They're gonna turn signal red, which means delete. And they're gonna get rid of those wire connections there. So what we need to do is we need to take the geometry coming out of the RBD constraint from rules, plug it into the RBD cluster node. We need to take our constraint geometry, because now we have it. And we also want to take our proxy geometry, which is a simplified version instead of high resolution. And we can actually, I think, display it with our null. And for some reason, it didn't, but it should be there. All right, let's recenter my view. All right, so I'm gonna select this node, press P on my keyboard, and you're gonna see there's a cluster attribute called cluster, and there's an icon next to it that is a basically a toggle for visualizing this attribute. So I'm gonna click, and when I do that, a new colors appear all over my wooden palette. What are they? These colors are clusters now that this node produces for us. You see, there's a actually, hang on. There's a two properties that we usually mess around in this node. First one's called size, and the second one is detach random detach option. And let's look at what each of them does. So I'm going to click middle mouse on my mouse while hovering over this size. And when I do that, this sort of increments appear. I can change this basically option by increments of points, 0.1 by 1, 10, 100, and even lower than that. So I want to start dialing this down and see what kind of result it gives me. And if I dial on the right side, that gives me that. I like perhaps this one. Actually, it's a little bit too low, so I'm gonna dial it down a little bit, something like this, and I'm happy with the ratio now. So this node has given us now a cool way to cluster our geometry. And I think if we put down an exploded view node and press R on the keyboard, we can see that these clusters have been established now, you see? And the way I can double check if that is true is press down Q on my keyboard and select the RBD cluster node. And what's going to happen is Houdini is going to say, please bypass the RBD cluster node and don't show me the result of it. And the same way, I can hold down Q again, select it once again, and this now is the result as a result of the RBD cluster node. So the result is much more believable, much more realistic, and how would chunks form in real life. All right, we're getting somewhere. We're having a lot of fun now, and we're setting us up for a successful simulation. All right, with that said, how about we start to mess around with our constraints? So where are our constraints? Here are our constraints. We have created them, but we haven't tagged them yet. We know that there are multiple types of constraints in Houdini, and one of them, or three of them, are glue constraints, soft constraints, pin constraints, or hard constraints. Now, I want to start kind of tag them. I want Houdini to know what are these constraints are supposed to be and how they should behave. And to do that, I'm going to select the RBD exploded node, press Alt-X on my keyboard to cut the node, basically delete it, and I'm going to take this first pin coming out of the RBD cluster node, bring it out, press Tab on my keyboard, and type in RBD Constraint Properties. And here is that node. I'm going to select it, and that is automatically going to establish connection between all three of those pins. And let's walk over what are those connections so we kind of know what we're doing. So the output coming from the RBD cluster is geometry, just a typical 3D geometry. So we plug that into the RBD constraint property that expects, see, geometry. We know what these pinkish pins are. This is our constraint geometry you see on here. This got a sort of spider webs. So we establish the connection between these two nodes. And obviously we have the proxy geometry, which is lower resolution geometry of our box here. So I'm going to put a display flag to the RBD constraint properties node. I'm going to press P on my keyboard. And there are a few things that we can change. And one of them is constraint type. Just a moment ago, I walked you through the three types of constraints we usually work with in Houdini, which were glue, soft, and pin. So, and we're going to see that by clicking, soft, glue, and hard. So if I click on this drop-down menu here, you'll see that indeed is true. We have glue, hard, and soft. I want to work with soft constraints for this box because, in my opinion, these wooden pallets are usually, maybe they have nails in them, and if you try to destroy them, it's not always that hard. I think they have some sort of flexibility and sort of like this rubber band effect in them, because I want you to think about these wooden pallets. Maybe you have experience working with them before, or maybe you have tried to destroy them. It's not that easy. You know, they're nailed together, and you would need to really hammer them down to even put this whole thing apart. So I think soft constraints is going to give us a more believable flexibility in this structure. So when it comes crashing down on the floor, it's gonna have this sort of like this bending, flexible rubber band sort of effect, which is I think is going to work for us in this scenario. And there's multiple options that we can set here, and namely is going to be stiffness and damping ratio. Stiffness is going to be responsible for how stiff or basically flexible the simulation is, and damping ratio is going to be responsible for it basically adds a little bit of weight to the whole simulation. So the higher the damping ratio, basically the more weight feels we're adding to the simulation or the wooden pallet. All right, but I want to work with specific settings that I've nailed down in my previous work. So what I will do is I'm going to press P on my keyboard. You don't have to follow at this moment. I will go ahead and try to find the RBD constraint properties from the work I did previously. And I'm going to try to remember these two settings. So it's going to be 6 for the stiffness, and damping ratio is 0.95. So remember these settings yourself, and let's plug them in. I'm going to go back to this node, press P on my keyboard. I'm going to press Ctrl V to paste over the stiffness setting. And here I can write either 0.95, or another handy thing you can do is you can just do 0.95, and that is going to work the same way. Either way works. Now, sometimes I do it this way, sometimes I do it the other way. It doesn't really matter. Okay. I think we're in a position to try to mess around with an RBD bullet solver. So I'm going to press Tab on my keyboard, type in RBD solver, and a new node is going to be found, which is called RBD bullet solver. And that's exactly what we need in this moment in time. So I'm going to click there, drag and drop it here. And we don't have no connections currently made, and that's okay. We can make it ourselves. So we have done this numerous times before. We already know what we need to do, right? So we take the geometry, plug it into the geometry, what RBD solver expects. We take the constraint geometry, these spider webs. We connect this. Obviously, a proxy geometry is going to come out of the RBD Constraints properties node. We take that, and hang on, going to press Y and delete this connection. So proxy geometry, and we plug that in as well. And these two are for the collision geometry and guided sims, which is not what we're looking at today. All right. With my timeline set to 1, maybe yours is set to some other number, I want you to click this thing. It's going to give basically put you in the frame 1 of this whole thing. And with that, press R on your keyboard, and let's activate the RBD bullet solver. I'm going to press P to get the settings for this node. And right away, a bunch of things are going to happen if you press play. Namely, if I press play, it's going to go through the ground. And the reason for that is very simple. We haven't told Houdini that there should be any collisions. Right now, it just drops into the nowhereness, okay? Into foreverness. We want to fix that. The way to fix that is by adding a collision or a ground. So I'm going to go over to the collision tab here. I'm going to find a ground collision ground type here. I'm going to say ground plane. And when I do that, a new basically ground plane is being created for us. And now if I press play, and if I zoom in a little bit on my viewport here so you can see the result a little better, is our pallet no longer goes through the ground, it hits the ground. Exactly what we want. But for my personal preference, these wires are very clutterly. It's not what we want. It's very hard to focus on what matters, which is the simulation at this point. So what I want to do is go into the visualization tab, and there's a show geometry setting. I'm gonna click there, and let's see. constraint geometry. Actually, I can untick constraint geometry, which you see in between the palette, and that's going to get rid of those lines. And okay, I'm gonna visualize geometry, and that's going to get rid of that. But you can also change the wireframe to shaded if that's what you want to do. So that's gonna give you that sort of look. So I'm gonna get rid of that. And I think the grid, if it's on and off, or should I say when it is on, it gives us a kind of a more appealing result in that sense. Okay, great. So if I press space H on my keyboard, press play, the simulation happens. Everything is great, and actually the effects is quite realistic. But there's another thing that I want to turn off, is I want you to focus on this right hand bar here, and if I scroll down, you're gonna see this little like check mark here that says visualization. If I click there, it's going to get rid of this look, and now I can look at my wooden palette as it probably would look in real life, or close to it. We have this beige color assigned to it, and that gives me a much more appealing way to now work with my simulation. And actually I can go even a step further than that by getting rid of the wireframes here. I'm gonna go at this little box here, select it, and I'm gonna say smooth shaded, and that's going to get rid of those wires. All right, I propose what we do now is I want multiple pieces of the same box coming out of the sky in the periods of 20 frames. So I have box coming down, pause, new box, pause, new box. So we have them raining down from the sky, and it's going to make this effect much more fun actually. How can we do that? Well, we need to go back to the RBD cluster node, so which is the third from the bottom. We're gonna make a new connection here, and I'm gonna say switch. And switch node is going to make this possible to help us switch from seeing geometry to not seeing geometry. You'll see what I mean in a second. And to make this a reality, what we need in our hands is an empty container, which we have seen already in this tutorial. Null, we're gonna call it empty. Empty, just empty, okay? We're gonna plug this into the switch node. And next what we need to do is we need to take the geometry, but it's coming out of the RBD material fracture. We're gonna plug this in. And now if I set my display flag to the switch node, press P on my keyboard, we see that we have two connections made. One is empty, which is basically empty space, and another one is RBD material fracture. So we want this switch node to basically choose a container, basically switch between an empty space and the RBD, not RBD, but wood palette. And the way we do that is we're with a specific code. I'm gonna press, actually, I think the code was every frame, which is $F. So $F is going to reference every frame. It's going to count down frame 1, frame 2, frame 9, all the way to whatever your frame is at this timeline. And I think I haven't mentioned this. When you click down on this little menu, you can change how, basically the length of your timeline. Maybe you don't have it set at 500 and you're wondering why it sits at like 100 or 80 frames. You can specify here whatever you want. Maybe you want the timeline to be 250 frames. You type that in, press space, click apply, close, and indeed your timeline is now 250 frames. I'm gonna slide down to the frame number 1. So I'm gonna say, I want to turn on the switch node every 20 frame and say that the result is true. So let's see, every frame and modulo 20 equals 1. So let's see if this works. I'm gonna click here. Okay, it does. How do you know? It's going to every 20 frame. If you open up your geometry spreadsheet, you're going to see every 20 frames it fires off empty geometry. So actually, if I go to the 20 frame and you look at your geometry spreadsheet, there's an empty space. Okay, and this is exactly what is going to give us this this breakup in our pattern there. All right, but let's look at how it looks like in the RBD bullet solver. So I'm going to set my display flag to it, and I'm going to press play and see what kind of result we have. And right now we don't have anything, and that is why we need to select the RBD bullet solver, go to the setup, and say emit RBDs. And I think if we have done our job right, I'm gonna press escape, revert my timeline, hit start, and it should theoretically give us that result. Okay, I'm gonna cancel out. I don't think that is happening for me at the moment. So let's troubleshoot this for a second. So let's see what this error is all about. Index out of range is not valid source. So we have this. Let's see. Let's go back. Actually, let's go back to my previous work and let's see where we have made a mistake. So, okay, so I'm gonna copy the code, go back to the switch node, and I think I might have missed. Oh, okay, there was a P slidden into this. That's why it didn't work. So I'm gonna paste this code. Actually, I'm gonna go back into this switch node, press P. I'm gonna copy this, go back into my switch node, and I'm gonna paste it. And now it should work. I don't know at what time the P all of a sudden appeared. So let's see. Okay, exactly. And I love this because these things happen as you work in Houdini. Sometimes you didn't notice what you did wrong, but you know, these things happen, and I'm actually glad this happened here because we can problem solve in real time and kind of fix problems as they arise. All right, what next can we do? Actually, how about we take a second to go into RBD bullet solver, press P on my keyboard, and how about we start kind of reeling in and tuning these constraints, because we haven't really touched them yet. We have created them, we have tagged them, but we haven't really tuned them to our taste. And by going into the constraint tab of our RBD bullet solver, we can see that there's two types of constraints set that RBD bullet solver can work with, soft and hard. We know that we're working with soft, so hard are excess. We don't need that, so I'm gonna delete that. And I'm gonna say delete constraints, but instead of distance threshold, which governs how the breakage should happen, I want to work with angle thresholds. And I'm gonna see if something like 0.24 maybe could help me to make a simulation a little bit realistic. And if you want to be very pedantic about this, I have spent maybe a better part of like an hour or two reeling in these settings. If I go into the collision setting, constraint settings of the previous work that I did, we can see that the angle threshold was set to 0.279. So I'm gonna press P on my keyboard, gonna go back into the RBD bullet solver, and I can put a setting in here. And that's going to give me a little bit more similar result than as in the beginning of this tutorial. Another thing we want to look is we want to go into the properties and change this density slider, which is basically a mathematical calculation to give us an accurate estimation of how this piece of pallet should weight. I don't know about you, but I landed on a setting 600. You're free to experiment and tune them to your taste, but I think 600 is going to give us a decent starting point. All right, and now if we have done our job right, revert back to the first frame, kind of pull our camera out a bit, and we're gonna press play. We should see a pretty cool result. Now we take a moment to look at our work. So this is most satisfying part of this whole Houdini work. And if I zoom in a little bit and see the breakage a little bit more, we can see how this effect pans out. Okay, and it's taking a lot of computer resources to make this happen. So the simulation is going to be as fast or as slow as three things. Number one, if you have enough RAM, so usually a middle ground is between 32 to 96 gigabytes of RAM for Houdini work. Second one is fast enough CPU, and RBD Bullet Solver usually calculates everything based on single core speeds. So the faster your single core speed of your CPU, the faster this is going to work for you. And the third one is so RAM, CPU, yeah, basically these two things. All right, so I'm quite happy as how it has turned out already. How about I show you a few settings or sliders that you can tune to your own liking to get different kinds of results. Well, my findings show that you can play around with density, which is basically the whole mass based on the volume of this wooden pallet. That can give you a better or worse results depending on this slider. You can reduce the friction or bounce, or maybe you don't like the bounciness to be as bouncy. Let's play this. Maybe it's too bouncy for you. You can turn this, I don't know, maybe something like 15, revert simulation back, and that's going to give you that. Or you can revert back to where it was, which was 0.25. All right. Next that you can mess around with is under the constraints, angle threshold. The higher the angle, usually the harder it will be to break this wooden pallet. So you can mess around with this. Also, you can change the distance threshold if you want that. And if you want, you can go into the, let's see, where is it node? And RBD Constraint Properties node, and you can change around the stiffness. Basically, how stiff or less stiff the RBD, the wooden pallet is going to be. 10 is going to be really stiff, 1 or below 1 is going to be less stiff. But another thing that I wanted to show you is, which I kind of, to be honest, forgot, is we can give a variation in how these boxes are being thrown out of the sky. Right now, it kind of spawns in one point and it drops right onto the ground. And the way we can kind of randomize that is by taking out a attribute randomize node. Here it is, and we can put it behind the switch node here. And we can use an attribute called velocity. In attribute name, I'm going to change CD to V, lowercase v, and I'm going to kind of make these all to zeros. And what you can do is you can type in something like a range. You can say -10 to 10, and with these kind of settings, you say, please spawn randomly my box from the -10 to 10. That's what it does basically. And now if I go into my RBD Bullet Solver, make sure I'm on the first frame, and at this point you want to reset the simulation. Otherwise, the RBD Bullet Solver kind of disregards that we have done this. I don't know why, it just happens. So you click reset simulation, and now if I press play, you see, we have this effect which kind of throws our wooden pallets into random directions and basically in random kind of way. And you can play around with the settings and numbers there to have different kind of effects or results. But this is as good as it is for this kind of tutorial. I'm gonna pause the simulation. I'm gonna go back here, and I would say we're done for the most part. And I want to thank you for sticking around and making this work and trying to better yourself in Houdini and learning destruction effects. It means a lot that you comment and share your results and ask questions, and kind of that we're doing this together. It really means a lot to me, and I'm glad that I can help you. And with that, I'm going to say thank you again, and I'm going to see you in the next one. Cheers.